Hello everyone, let us check the case study. Novel node distribution strategies in corona-based wireless sensor networks. I'm Huei-Wen Ferng. Outline will have an introduction. We will then have the introduction to wireless sensor network and its issues. And actually, we will talk about the research contribution of the article. And related word, we will check these related words. And network model and the definition. Later, we will have the suitable network model, and of course, we need to have the definition to make assumptions simple. And finally, we will have the analysis, not finally, but later we will have analysis on the uniform node distribution strategies. We will have optimal sensor node placement. And we will have lower bound on the number of sensor nodes deployed in Corona. And we will have energy depletion analysis. Of course, we will have balanced energy depletion analysis. Alright, so almost all. And actually, we will have the proposed solutions, strategy 1, 2. Alright, and for this, we will have the corresponding performance evaluation and discussions. Alright, and of course, we will have the reference schemes, and we will have the evaluation arrangement and shown results and discussion. Finally, we will have the conclusions. First of all, introduction. Wireless sensor network. Here you can see a wireless network formed by a large number of autonomous sensor devices. Then we will have a wireless sensor network. And sensor network is used to monitor physical condition of an area of interest. And possible applications of wireless sensor networks include disaster relief, environment control, and biodiversity mapping, security system, etc. So the issues talked about in this article, we will talk about the following constraint. Sensor node power source, actually it is limited. With the limited power source, and then how to have the proper mechanism. Of course, if we allow the sensor node to die, and then we will form the energy hole problem. So in this article, it tried to ask this question: is it possible to let all sensor nodes die simultaneously in a wireless sensor network, so that we can prolong the operation time to the longest one? So this is the issue asked by this article. Well, our contribution, actually this is article written by me. So our research contribution, we solve the coverage problem in a corona-based wireless sensor network, and so that we can give the optimal node position, alright, and lower bound for the number of nodes that should be deployed within a corona, and shown the complete balanced energy depletion in a corona-based wireless sensor network is achievable. Of course, we should have some proper design, so achievable. Well, so finally, we'll address the two strategies, strategy 1 and strategy 2. As for the detailed design, we will discuss later. Related word. So we have a non-uniform initial energy distribution. That says it doesn't mean we should have the same levels. If so, then we have the non-uniform initial energy distribution. And to avoid unbalanced energy depletion, in fact, we can try to use mobile things. Let's say thing can move, and so that we have a mobile thing. Because of mobile things, of course, it doesn't mean we'll always allow all the sensor node, all the fixed sensor node surrounding the thing consume energy first. So of course, if we have the mobile things, and then we can avoid those nodes surrounding thing to die first. And to have the other way to address the issue, we can have energy-aware routing protocols and energy-aware node distributions. Alright, so right now that is defined network model, and also we have some proper definitions for the later utilization. First of all, network model. In fact, something like we have the corona defined how to have a different corona. This one we call non-uniform phi corona model because we don't have the same width here, so that's why we have the non-uniform phi corona model. If we always have the same radius and same width for all of the corona, then we call it a uniform corona model. For the corona model, of course, we can have the way to have the energy consumption. Alright, so you can look at these. As for the other assumptions, we assume homogeneous initial energy. It doesn't mean we have non-homogeneous initial energy. And each active node is required to generate and send L bits of data. So the fixed length and through multi-hop communication. However, we don't have the other further assumptions, so that we have the ideal MAC layer and actually no collision and no retransmission. And of course, in wireless sensor network, you should have the data aggregation, but the current consideration, we don't have the assumption for data aggregation. So data aggregation is not considered in this article. Well, here we should have the definition first because we need to pass on the definition to have the further deviations. First of all, we define corona lifetime, and then we have a network lifetime, and how to have a balanced energy depletion. Well, I think you can look at the current definition. To have a corona lifetime, network lifetime, and what it means if we have balanced energy depletion. So make it simple, I just circle them and so that you can refer to the current definitions. Right now, let us have the analysis on non-uniform node distribution strategies. Well, first of all, we derive the optimal node placement, and so that we have the optimal sensor node position. And in fact, you can look at the article to have the theorem, and later we can pass on the theorem to have the design for our proposed strategies. So this is the optimal position for the sensor node. Of course, if you want to have the derivation, then you can move it and then you can find how to have the optimal sensor node placement. We try to maximize the coverage. If we can find the position and so that the coverage is maximized, and then we will put node to that position. So this is the way to have the optimal sensor node placement. Once we can have that derivation, then we can try to have the suitable separation. The suitable separation to let us have the lower bound of the number of sensor nodes required and deploy in a corona. Alright, so in fact, we can pass on the suitable or the minimal angle and define the minimal angle so that we can have the maximum separation, still have the proper coverage, and then we can find the lower bound on the number of sensor nodes deployed in a corona. And here, this is the energy depletion analysis. How to have the corresponding energy depletion. We can have the corresponding way. And actually, we have some assumption. And likewise, I make a sample, so you can look at the current page, or maybe you can refer to the paper to know how to have the energy depletion. All right. And this is a balanced energy depletion analysis. And we have the further theorem. It is called theorem 2. We assume if we have the non-uniform corona and find the width for this, and when we can have the suitable one, and then we can achieve balanced energy depletion. Again, it can be proven properly, but we don't know we have this condition. And based on this theorem, later we can have a design. And here we have a calorie 2. And based on this one, then we can have some results. For example, we can have the result, and so that we can have the second design. Alright, so based on the theorems derived here and the calorie derived here, and then we can have the strategy design, so we call proposed solutions. So first of all, strategy 1. Based on the optimal balanced energy depletion to have the width, and so that we find DO, and once we have a DO, we follow one method proposed in an article, and that is called the reference one, and later we can show that reference one. So based on the reference one, how to set, actually we follow this way to set the number of nodes. So find D and DO. So here we have the illustration. If we have 5 corona model, so D will be the current value, and the DO will have this value. And follow that set, and we can have the number of nodes setting. So this is the proposed strategy 1. Alright, so we can have the corresponding set for the number of nodes. And in fact, we should have the corresponding switching. Here we have the switching or routing like this. And strategy 2 will follow calorie 2, and so that we can have this kind of design. And in fact, I make it simple, just follow calorie 2 to have the design. And also we have the optimal position according to theorem 1. And strategy 2, we have switch scheduling to allow node to go to the sleep mode. Alright, so about that one, we have some switch scheduling in the algorithm. Alright. So how to have the calculation, because we based on a uniform one, so this time it won't be necessary to calculate the width of the corona. Instead, we need to have the optimal position. So we get optimal position, and as for number of sensor node, we follow the derived calorie. That says calorie 1 to have the number of setting, and actually we can have the corresponding energy consumption, because we have some node to go to the sleep mode. So of course we can save energy for this strategy. Alright, so that's it. And here we show how to have switch scheduling. That says allow some node to be active and some node to be in active mode. Here, this one, sensing, and then switch, sensing, and etc. So we can have this way switch scheduling. Well, about the performance, we can check. Of course, we use some calculation, and also we have some other tool to have the simulation. And previously, we mentioned how to set the number of nodes for our strategy 1 based on one scheme called Wu scheme in the literature. And to have another benchmark, we have a uniform scheme. That says you have the uniform way to have the spacing, to have the separation in space, and so that we can have the equal spacing for all of the nodes. And here we have the set for the parameters. Well, to have a vision on the possible deployment, we have a Wu scheme, and our strategy 1 even looks almost similar, but later we can show you the difference. And as for our strategy 2 and uniform, here you can see we have a uniform, right? And this is the performance about residual energy. And the Wu scheme, we have a residual energy. But for our strategy 1, we don't have a residual energy because we can achieve balanced energy depletion. If we check it further about variance of the residual energy and the residual energy ratio, actually we almost have a 0 for our strategy 1, and Wu scheme maybe a bit, and for our strategy 2, maybe something should be corrected, but still near this. All right, so we have strategy 2, and also for uniform, it's so bad, so we don't have the less residual energy ratio. All right. In fact, something wrong with the current result, but I don't have the correction, but still can serve as reference, so I let you know these. If we have the further comparison, then we have these. All right. And talking about network lifetime, which scheme can have the longest network lifetime? Second strategy, because we have the switch scheduling, so we can prolong the network lifetime. As for the details, we can have a table to show how many runs for the individual scheme. And this is a network lifetime for the comparison. And total number of sensor nodes required. You can look at this. Our strategy 2 and the uniform, actually we have less number of sensor nodes. However, for Wu scheme, the most one, and then it's strategy 1. Conclusions. So we talk about coverage problem of the corona-based wireless sensor network and try to have the optimal sensor node position. Right, and to have the balance, to have a lower bound on the number of sensor nodes to be deployed, and to have the proper strategy 1 and 2, then we can have some goal to achieve, to have the proper coverage, to have a durable network lifetime, and to have efficient use of sensor nodes. And of course, we make sure it's possible to have balanced energy depletion so that we can have our design of strategy 1. And of course, using strategy 2, we can have longer network lifetime and also efficient use of sensor nodes. Of course, strategy 1, if we have a small wireless sensor error, it can be recommended to be employed. As for strategy 2, actually, if we want to try to have a cost-effective one, then we can use it. Of course, if we have a larger area, we can use it as well. And that's all, and thank you for your listening. This is our case study. All right, thank you. Bye-bye.